similar to the case of a simple linear regression model, we need to have sample data to estimate the unknown parameters betas in the model, and we will use the same estimation method, which is called least squares estimator. So after we use the sample data and we apply least squares estimator, we get some regression model. So the general form is presented in front of you. We can rearrange this expression to get the value for the error term. That would be y minus the estimated model. So in other words, the error term is the difference between the actual value of y and its estimated value. And to get the sum of squared error terms, what we do is just we take this difference and we square it. So, and as we already know, the least squares estimator operates in the following way. So it chooses the values of beta 0, beta 1, beta 2, and all the way to beta k in such a way that the sum of the squared errors is as minimum as possible. And the interpretation of the estimates of betas in multiple regression model will be very much similar to the simple linear regression model. So as in case of the simple linear regression model, beta 0 is the intercept and it represents the predicted value of y when all x's, so when all the independent variables are 0. As for the slope, so for example, beta 1 slope represents the increase, or if it's negative, a decrease in y for every 1 unit increase in x1, keeping all the other x's constant. So when we hold all x's, x2 and all the way to xk constant, when when x1 increases by 1 unit, y will either increase or decrease by beta 1 units. And let's have a look at the example. So for example, a collector of antique grandfather clocks sold at auction believes that the price received for the clocks depends on both the age of the clocks and the number of bidders at the auction. And the following regression results were obtained for 32 clocks. So y is the auction price in dollars, negative 1,339 is the intercept, 12.71 is the first coefficient, where x1 is the age of clock in years, plus 85.95 were multiplied by x2, which is number of bidders. So the interpretation of the intercept would be the following. So when both the age of the clock and number of bidders, so when both x1 and x2 are 0, y, the auction price, is equal to negative $1.339. And the question is, does it make sense? I personally think it doesn't, because I don't think a price can be negative. Then let's move to the interpretation of 12.74. So keeping the number of bidders constant, so keeping the other variable x2 constant, when the age of clock goes up by 1 year, the auction price increases by $12.74. And the interpretation of 85.95 would be the following. So this time we keep the first variable constant, so we keep the age of clock constant. When the number of bidders goes up by 1%, the auction price increases by $85.95.